Now let's go through exercise 13.3. First question. An urn contains 5 red and 5 black balls. A ball is drawn at random. Its color is noted and is returned to the urn. Moreover, 2 additional balls of the color drawn are put in the urn and then a ball is drawn at random. What is the probability that the second ball is red? Okay, so here we are drawing 2 balls. Okay, in first time there are only 10 balls. Okay, and so here see, one ball is drawn and noted its color and returned it to the urn, and then same color balls, okay, 2 balls of same color drawn are put in the urn and again drawn another ball. Okay, so here we have to find the probability of second ball is red. Okay, the red ball is drawn in the second draw. Okay, so here we have to find the probability of red ball is drawn in second row. Now let's take, let E1 be the event. Red ball is drawn. Here we don't know what is taken, that is which ball is drawn. Okay, red, either red or black. Okay, so here red ball is drawn in first draw. Okay, and E2 be the event. Black ball is drawn in first row. And we have to find the probability of second ball is red. That is, red ball is drawn in second row. So let's take, let E be the event. Red ball is drawn in second draw. Okay. Now, what is probability of E1? There are 5 red balls. Okay, in first case, it is in first row. So, at the time of first draw, there are only 10 balls, right? So, total 5 red balls and total 10 balls. Okay, so 5 divided by 10, that is 1 by 2. And probability of E2, it's also black balls is drawn in first draw. Okay, at the time of first draw, there are only 10 balls. Therefore, probability of E2 is equal to 5 black balls. So, 5 divided by 10, that is also 1 by 2. Okay, next. Here, what we have to find? We have to find probability of E. Probability of E. So, here we will apply total probability theorem. That is, probability of E is equal to probability of E1 into probability of E given E1. Okay, plus probability of E2 into probability of E given E2. Okay, now what is probability of E given E1? See, here probability of E given E1 is nothing but probability of red ball is drawn in second draw, given that red ball is drawn in the first draw. Okay, if we draw red ball in first draw, so how many red balls at the second time? Second time there are 7 red balls, right? Because see here it is mentioned that, see, its color is noted and it is returned to the urn. Moreover, 2 additional balls of the same color also added. 2 more balls also added, right? So if it is probability of red ball is drawn in the second row, given that red ball is drawn in the first row. Okay, so first draw ball is red. Okay, so there are total 5 red balls. Initially it was 5 and plus 2, that is 7 red balls. Okay, at the time of second row there are 7 red balls. Okay, so here 7 divided by and total 12 balls, right? So 12 balls. So the 7 divided by 12. Probability of E given E1 is 7 by 12. And what about probability of E given E2? What is probability of E given E2? Probability of red ball is drawn in second draw, given that black ball is drawn in first draw. Okay, so black ball is drawn in first draw. And we have to find, see, probability of red ball is drawn in second draw. So red ball is drawing second row, but there are 7 black balls. Okay, but here we need number of red balls, right? So there are only 5 red balls because in first time drawn ball is black. Therefore there are 7 black balls, 5 red balls. Therefore here 5 divided by and total balls 12. Okay. Now let's substitute these values here in this formula. That is probability of E, that is probability of red ball is drawn in second row is equal to probability of E1 is 1 by 2 into probability of E given E1 7 by 12 plus probability of E2 1 by 2 into probability of E given E2 5 by 12, that is equal to 7 by 24 plus 5 by 24 is equal to 12 by 24, that is 1 by 2. Therefore, probability of red ball is drawn in second row is equal to 1 by 2. A bag contains 4 red and 4 black balls. Another bag contains 2 red and 6 black balls. One of the 2 bags is selected at random and a ball is drawn from the bag which is found to be red. Find the probability that the ball is drawn from the first bag. See, here we have to find probability of the first bag given that it is red. Okay. Now, so first of all, let's take, let E1 be the event, first bag is selected. Okay. First bag is selected. And E2 be the event, second bag is selected. Okay, there are 2 bags. Okay. Now, we have to find the probability of first bag, that is E1, given that it is red. Right? So, here, let's take, let E be the event, see, which is found to be red. Right? So, red ball is drawn. Red ball is drawn. Okay. E be the event, red ball is drawn. Now what we have to find? Don't be confused here. We have to find the first bag, that is probability of first bag, that is E1 given that A. Okay. E, right? Okay. E is the red ball is drawn. Okay. So probability of E1 given E. Okay. Now this one we have to find. Here we will apply Bayes theorem. So what is Bayes theorem? Probability of E1 given E, that is equal to probability of E given E1 into probability of E1 divided by probability of E. Right? So it is not given. What is probability of E? So this one, here we will write total probability theorem formula. That is probability of E is equal to, okay, probability of E given E1 into probability of E1 divided by probability of E is equal to probability of E1 into probability of E given E1 plus probability of E2 into probability of E given E2. Okay, it is the total probability theorem. And totally it is called Bayes theorem. Okay. Now, what is probability of E1? Probability of E1 is equal to, probability of E1 means probability of first bag is selected. There are only 2 bags, right? So that is 1 by 2. Probability of E2 is also 1 by 2. Okay. And next is, see what we need to find? Probability of E given E1. That is probability of red ball is drawn when given that it is E1. Okay. So from the first bag. So from the first bag, how many red balls? 4 red balls. Total 4 plus 4, 8 balls. Right. So here probability of E given E1. E is nothing but red ball. Okay. So 4 divided by 8. That is there are 4 red balls out of 8 balls in first bag. Okay. That is equal to 1 by 2. And probability of E given E2. that is equal to, see, probability of red ball is drawn given that second bag is selected. Okay. So from the second bag, so what is the probability? So from in the second bag there are 2 red balls. Okay. So 2 divided by total 8 balls, right? So 2 by 8, that is equal to 1 by 4. Now let's substitute these values here. That is probability of, this one we have to find, right? So probability of first bag given that red ball is drawn. Okay. So it is equal to probability of E given E1 1 by 2 into probability of E1 1 by 2 divided by probability of E1 1 by 2 into probability of E given E1 1 by 2 plus probability of E2 1 by 2 into probability of E given E2 1 by 4. That is equal to 1 by 4 divided by 1 by 4 plus 1 by 8. That is equal to 1 by 4 divided by 3 by 8, right? It is 2 plus 1. So 3 by 8, that is equal to 1 by 4 into 8 by 3. So 2 by 3. Therefore, here probability of first bag given that red ball is drawn is equal to 2 by 3. Of the students in a college, it is known that 60% reside in hotel and 40% are day scholars. Day scholars means not residing in hostel. Previous year research report that 30% of all students who reside in hostel attain A grade and 20% of day scholars attain A grade in their annual examination. So at the end of the year, one student is chosen at random from the college and he has an A grade. What is the probability that the student is a hosteler? See, first of all, look at the question. See what you have to find. Okay. See here, first of all, let's see what we have to find. What is the probability that the student is a hosteler? When the student is chosen at random from the college and he has a A grade. Okay, so here we have to find the probability of hosteler given that that student attain A grade. Okay, so here first of all let's take, let E1 be the event student is hosteler. Okay, two types of students are there. One is hosteler and day scholars. Okay, that is, let E2 be the event student is day scholars. Okay. Now, and let E be the event student attains A grade. Okay, student attains A grade. Now, what we have to find? We have to find the probability of student is a hosteler, that is E1, given that student attains A grade. That is, we have to find probability of E1 given E. Okay. So here probability of E1 given E. Apply Bayes theorem. So here probability of E given E1 into probability of E1 divided by probability of E. What is probability of E? Apply total probability theorem formula. That is, probability of E is probability of E given E1 into probability of E1 into probability of E given E1 plus probability of E2 into probability of E given E2. Okay, it is the formula. Now let's find one by one. See, probability of E given E1. What is probability of E1? Probability of E1 is nothing but, see, 60% students are residing in a hostel, right? So here 60 divided by 100 and probability of E2 40%, right? That is 40 by 100. Okay. And probability of E given E1, that is probability of student attains A grade given that from where? In E1, that is from residing students, from residing in hostel students, okay, students those who residing in hostel. So here, see here it is given that 30% of all students who reside in hostel attain A grade, that is 30 divided by 100, okay. Therefore, probability of E given E1, that is probability of student attains A grade from given that E1, okay. So E1, we selecting from E1, that is students those who residing in hostel, okay. So here it is given 30% of the students residing in hostel attain A grade, okay. Therefore it is 30 by 100. And what is probability of E given E2, that is probability of student attains A grade from where? So from given that, see, the students, those are day scholars, okay, attain A grade in the A grade, that is 20%, okay. So it is probability of E given E2 is 20 by 100. Now substitute this here. Probability of E given E1, 30 by 100, that is 3 by 10, into probability of E1, 6 by 10, divided by 6 by 10 into 3 by 10 plus 4 by 10 into 2 by 10, that is equal to here 18 divided by 100 divided by here 18 by 100 plus 8 by 100. So 100 cancelled. So 18 divided by 18 plus 8, 26, that is equal to 9 divided by 30. In answering a question on a multiple choice test, a student either knows the answer or guesses. Let 3 by 4 be the probability that he knows the answer and 1 by 4 be the probability that he guesses. Probability, assuming that a student who guesses at the answer will be correct with the probability 1 by 4, what is the probability that the student knows the answer given that he answered it correctly? See here students answering a question in two types. That is, either he knows the answer or he guesses, okay. So here, so for that let E1 be the event, student knows the answer. If student knows the answer means the answer is correct, right? Okay. And another type is E2 is the event, student guesses the answer. If student guesses the answer either correct or wrong, right? Okay. So here, now what we have to find? We have to find the probability of the student knows the answer, that is probability of E1, okay. Knows the answer, not only probability of E1, given that he answered it correctly, okay. So let's take another event, E be the event, student answers correctly, okay. Because here we have to find probability of the student knows the answer given that he answered it correctly, okay. So E be the event, student answers correctly. So what we have to find? Probability of student knows the answer, that is E1, given E, right? That is equal to, apply Bayes theorem. Probability of E given E1 into probability of E1 divided by probability of E1 into, here apply total probability theorem, that is probability of E1 into probability of E given E1 plus probability of E2 into probability of E given E2, okay. That. Now let's find it one by one. So what is probability of E1? It is given directly, right? Let 3 by 4 be the probability that he knows the answer. What is E1? Students knows the answer. So probability of students knows the answer is 3 by 4. What is probability of E2? probability of student guesses the answer, that is 1 by 4. See, and 1 by 4 be the probability that he guesses. Okay, so 1 by 4. Now, what is probability of E given E1? See, probability of E is nothing but student answers correctly. Okay, probability of student answers correctly given that, okay, given that students knows the answer. See, students knows the answer means all answers are correct, right? So here the probability is nothing but 1. Okay, students answers correctly. We will select the students answers correctly from where? From the event E1, that is students knows the answer. We know that students knows the answer means all the answers are correct, right? So the probability is nothing but 1. Okay, and what is probability of E given E2? That is student answers correctly given that student guesses the answer. Okay, it is given here. That is assuming that a student who guesses at the answer be correct with the probability 1 by 4. Okay, so its probability is 1 by 4. Now substitute. So probability of E1 given E. Okay, that is probability of student knows the answer given that he answers the question. Sorry, he answer it correctly is probability of E given E1 1 into probability of E1 3 by 4 divided by probability of E1 3 by 4 into 1 plus probability of E2 1 by 4 into 1 by 4. Okay, that is equal to 3 by 4 divided by 3 by 4 plus 1 by 60. That is equal to 3 by 4 divided by here 18 plus look at the next question. A laboratory blood test is 99% effective in detecting a certain disease when it is in fact present. However, the test also yield a false positive result for 0.5% of the healthy person tested. Its meaning, that is, if a healthy person is tested, then with the probability 0.005, the test will imply he has the disease. Okay. If 0.1% of the population actually has the disease, what is the probability that a person has the disease given that his test result is positive? Okay. Now, here, see two types of person, right? That is, one is diseased and another one is healthy persons. So, let's take, let E1 be the event, the person has disease. And E2 be the event, the person is healthy. Okay, the person has no disease, that means the person is healthy. Okay, and what we have to find? See, what is the probability that a person has the disease, means probability of E1 given that his test result is positive. Okay, so let's take the event E be the event, the test result is positive. Okay. Now, what is probability of E1? See, the probability of E1, the person has disease. Okay. See, here it is given 0.1% of the population actually has the disease. So, what is the probability? 0.1%, that is 0.1 divided by 100, that is 1 by 1000. What is probability of E2? That is probability of healthy persons. See, here there is only one diseased person out of 1000. So, how many healthy persons are there? That is 1000 minus 1 out of 100, out of 1000, right? So, that is 999 out of 1000 persons are healthy. Okay. So, here next, what is probability of, what we have to find? We have to find probability of a person has the disease given that test result is positive. That is probability of E1 given that E. Okay, that we have to find. So here we will apply Bayes theorem. For that we have to find probability of E given E1. That is probability of test result is positive from this person given that the person has disease. Okay, that is here, see it is given 99% effective in detecting a certain disease when it is in fact present. That is here all the diseased persons are, their result must show positive, right? So 99% are diseased. Okay, so here what is the probability of E given E1? 99%. That is 99 divided by 100. Okay. Next, probability of E given E2, that is equal to, here the test result is positive, that is probability of the test result is positive when the person is healthy. It is given that the person is healthy. Okay. So here it is given that, see, the test also yield a false positive result 0.5% of the healthy person. Okay. So when healthy persons are tested, so it shows that their result is positive. How many persons? 0.5%. That is probability is 0.5 divided by 100. That is 5 by 1000. Okay. Now let's apply the formula, that is Bayes theorem. We have to find probability of E1 given E. That is equal to probability of E given E1 into probability of E1 divided by probability of E1 into probability of E given E1 plus probability of E2 into probability of E given E2. Substitute all these values. Probability of E given E1 99 by 100 into probability of E1 1 by 1000 divided by, it is 1 by 1000 into 99 by 100 plus 999 divided by 1000 into 5 by 1000. So that is equal to, say it is 99 divided by 1 lakh, right? Divided by, here 99 into 1, 99, 99 divided by 1 lakh plus, see here 5, 200, right? 5 cancelled, so 200. So it will be 999 divided by 2 lakh. That is equal to, see here 1 lakh cancelled. Okay, so multiply 2 here, then it will be 99 divided by 1 lakh cancelled, then here 2 is remaining. Okay, after cancelling 2 is remaining because here LCM is 2 lakh, and multiply 2, after multiplying 2 here or taking LCM here, so the LCM is 2 lakh and take this 2 here numerator, so it will be 198 divided by, here 198 plus 999, that is equal to 198 divided by 7, 9, 11. Okay. There are 3 coins. One is a 2-headed coin, or that is having head on both faces. Another is biased coin that comes up heads 75% of the time. And third is an unbiased coin. One of the 3 coins is chosen at random and tossed, it shows head. What is the probability that it was the two-headed coin? There are 3 coins, one coin is tossed. Okay, so 3 types of coins. One coin is, first is two-headed coin. Okay, so let's take, let E1 be the event. The coin tossed is two-headed. Okay, that means this coin has 2 heads, okay, on both sides. So here, next let E2 be the event. See, next coin is biased coin. That is a coin which has either head on both sides or tails on both sides. Okay. So here such coins are biased coins. Okay. So here let's take, let E2 be the coin tossed is biased coin. And third coin is unbiased coin. That is, unbiased coin is a coin which have head and tail on either side. Okay. So here let's take, let E3 be the event. The coin tossed is unbiased coin. Okay, that is the coin which have head and tail on either side. Okay. So here 3 types of coins. One coin is tossed. And what we have to find? See, look at the question. Here, see, the coin is chosen at random and tossed. It shows head. Okay, it shows head. What is the probability that it was the two-headed coin? That is probability of E1 given that it shows head. Okay, given that it shows head. Therefore, let's take another event. Let E be the event getting head or shows head. Okay. Now, what is probability of E1? There are total 3 coins. So, one coin that is two-headed coin. There is only one two-headed coin, that is 1 by 3. Okay. And probability of E2 also same thing, that is 1 by 3. There are total 3 coins. Okay. So, probability of E3, that is also 1 by 3. Okay. Next, what we have to find? We have to find probability of, see, it was the two-headed coin given that showing head is already occurred. That is, given that it shows head. That is probability of E1 given E. That we have to find. Applying Bayes theorem formula. So for that we need to find probability of E given E1. That is probability of getting head given that the tossed coin is two-headed. See, there are only 2 heads, right? Only 2 heads, right? There is no other tail, there is no tail. Therefore, here we get only head. Okay. So here what is the probability? Probability of getting head out of this one. That is nothing but 1. Probability is 1. Because there are only head. There is no tail, right? Therefore, here we will get the probability is 1. Okay. Probability of getting head out of this one is nothing but that is 1. Okay. Because there are 2 head on both sides. Okay. Next, probability of E given E2. What is E2? The coin tossed is biased coin. Biased coin means 2 heads on both sides or 2 tails on both sides. Okay, that we don't know. So here it is given. See, another is biased coin that comes up heads 75% of the time. 75%. So its probability is 75%. So 75%, that is 75 divided by 100. That is 3 by 4. Okay. Now probability of E given E3. Probability of E given E3. That is equal to, that is probability of getting head given that third coin is tossed. Okay. That is, what is the third coin? Unbiased coin. That is, we will get either head or tail. This coin has head and tail on either side. Okay. So when we toss it, we will get either head or tail. Right. So here probability of getting head when that is given that this third coin is tossed, that is unbiased coin is tossed. So here we will get either head or tail. So what is the chance of getting head? 1 by 2. Right. So here the probability of getting head given that third coin is unbiased coin is tossed is 1 by 2, because the chance of getting head is 1. That is 1 by 2. Right. So here 1 by 2, that is probability of getting head given that third coin is tossed is 1 by 2. Okay. Now we have to find probability of E1 given E. Bayes theorem. Probability of E given E1 into probability of E1 divided by probability of E1 into probability of E given E1 plus probability of E2 into probability of E given E2. Substitute these values. Probability of E given E1 1. 1 into probability of E1 1 by 3 divided by probability of E1 1 by 3 into 1 plus probability of E2 1 by 3 into, yes, 3 coins are there, right? So here we have to, yes, here 3 events are there, therefore we have to write one more term here, that is probability of E3 into probability of E given E3. Okay. So here 1 by 3 into 3 by 4 plus probability of E3 1 by 3 into 1 by 2. Okay, because there are 3 events. Okay, E1, E2, E3. That is equal to 1 by 3 divided by here 1 by 3 plus here it is 1 by 2. Okay. It is 3 cancelled. So 1 by 4 plus 1 by 6. That is equal to 1 by 3 divided by 3, 4, 6. So 12 is the LCM, right? So here 4 plus here 3 plus 2 divided by 12. That is equal to 1 by 3 into 12 divided by 4 plus 3, 7, 7 plus 2, 9. That is 3 4s are, okay. So 4 by 9. So probability of getting probability of two-headed coin given that it shows head is 4 by 9. An insurance company insured 2,000 scooter drivers, 4,000 car drivers and 6,000 truck drivers. The probability of an accidents are 0.01, 0.03 and 0.15 respectively. One of the insured persons meets with an accident. What is the probability that he is a scooter driver? Okay. So here first of all let's write a total number of insured persons. Okay. So total number of insured person is 2,000 plus 4,000, 6,000, 6 plus 6, 12. So 12,000. Right? Next, here, see, first one is insured persons. What are the insured persons? One is scooter drivers. Okay. Next, car drivers and truck drivers. So here, let's take, let E1 be the event. The insured person is scooter driver. Okay. E2 be the event. The insured person is car driver. E3 be the event. The insured person is truck drivers. Okay. Now, what we have to find? See, we have to find, see what is given? One of the insured person meets with an accident. We have to find what is the probability of, that is a scooter driver, given that insured person meets with an accident. Right? So, here the given that. So, here what is the event? Event E be the event. The insured person meets with an accident. Right? Because we have to find probability of a scooter driver given that insured person meets with an accident. Okay? So here, first of all, probability of E1. See how many probability of E1. E1 is the event, insured person is a scooter driver. So how many scooter drivers are there? 2000 out of 12,000 drivers. Right? So here, probability of E1 is 2000 divided by 12,000. That is equal to 1 by 6. Probability of E2, insured person is car driver. There are total 4,000 car drivers out of 12,000 insured drivers. Okay. So 4,000 divided by 12,000, that is 1 by 3. And probability of E3 is the event, insured person is a truck driver. There are total 6,000 truck drivers. Okay. So probability of E3 is 6,000 divided by 12,000, that is equal to 1 by 2. What we have to find? We have to find probability of scooter driver given that insured person meets with an accident. Right? So probability of E1, okay, given that E. Okay. So here also we will apply Bayes theorem. So for that, let's find what is probability of E given E1. That is given, right? Yes. See here, the probability of an accidents are scooter driver, car drivers and truck drivers. Okay. So probability of E given E1 0.01, 0.01. Okay. And probability of E given E2 0.03 and probability of E given E3 0.15. Now we have to find probability of E1 given E, that is probability of a scooter driver given that insured person meets with an accident. Okay. So it is equal to Bayes theorem. Probability of E given E1 into probability of E1 divided by, there are 3 events. Okay. So probability of E1 into probability of E given E1 plus probability of E2 into probability of E given E2 plus probability of E3 into probability of E given E3. That is equal to probability of E given E1 0.01. So 0.01 into probability of E1 1 by 6 divided by, here 1 by 6 into 0.01 plus probability of E2 1 by 3 into 0.03 plus probability of E3 1 by 2 into 0.15. Okay. That is equal to, here let's cancel these decimal points. Okay. So multiply 100 here, that is 1 by 600 divided by, here also 1 by 600 plus here 3 divided by 300 plus here 15 divided by 200. That is equal to 1 by 600 divided by, here 600 is the LCM. So here multiply 2. So 1 plus 6 plus 45 divided by 600. 600 cancelled. Then it is equal to 1 divided by 7. 7 plus 45, that is 52. So 1 by 52 is the answer. A factory has two machines A and B. Past record shows that machine A produced 60% of the items of output and machine B produced 40% of the items. Further, 2% of the items produced by machine A and 1% produced by machine B were defective. Okay. All the items are put into one stockpile and one item is chosen at random from this, and it is found to be defective. Okay. What is the probability that it was produced by machine B? Okay. So there are two types of machines, machine A and machine B. So let's take, let E1 be the event. Item is produced by machine A. Okay. And E2 is the event. Item is produced by machine B. Produced by machine B. Okay. Now what we have to find? See, all the items are put into the one stockpile and one item is chosen at random. See, from this, and it is found to be defective. Okay, we have selected a defective product. Then what is the probability that it was produced by machine B? That is, probability of item produced by machine B given that it is defective. Okay, so let's take another event, event E. E is the event defective product. Okay, item is defective. Okay, what we have to find? We have to find probability of item produced by machine B given that it is defective. That is, we have to find machine B, right? This one, E2. So E2 given E. This one we have to find. Okay. Now, what is probability of E1? Probability of E1, it is given that, see, machine A produced 60% of the items, right? So 60 divided by 100, that is 1 by 6. Sorry, 6 by 10. Okay, let it be here. Okay. Then probability of E2. Probability of E2 is 40 divided by 100. Okay. Next, probability of E given E1. That is, probability of defective item given that machine, that is item produced by machine A. Okay, machine A, that is, it is given here, right? 2% of the item produced by machine A are defective. Okay, so 2%, that is 2 by 100. Okay, next, probability of E given E2, that is 1%, right? So 1 divided by 100. Now, from base theorem, probability of E2 given E, this one we have to find, right? Probability of E2 given E is probability of E given E2 into probability of E2. You should be careful here. If you have to find probability of E2 given E, here E2, okay? Probability of E given E2 into probability of E2 divided by probability of E1 into probability of E given E1 plus probability of E2 into probability of E given E2. Okay, that is equal to probability of E given E2 is 1 by 100 into probability of E2 is 40 by 100 divided by probability of E1 60 by 100 into probability of E given E1 2 by 100 plus 40 by 100 into 1 by 100. See here, in numerator, denominator, 100 into 100, that is cancelled. So it is equal to 40 divided by, it is 120 plus 40, that is equal to 40 divided by 160, that is equal to 0 cancelled. So 1 by 4. Two groups are competing for the position on the board of directors of corporation. The probabilities that first and the second groups will win are 0.6 and 0.4 respectively. Further, if the first group wins, the probability of introducing a new product is 0.7 and the corresponding probability is 0.3 if the second group wins. Find the probability that the new product introduced was by the second group. So here there are two groups. So here let's take first group and second group. Okay. So let E1 be the event first group wins. Okay. And E2 be the event second group wins. See here it is given the probabilities of first and second groups will win are 0.6 and 0.4. Okay. That is probability of E1 is equal to 0.6, probability of E2 is equal to 0.4. And if the first group wins, the probability of introducing a new product, that is 0.7. Okay. And if second group wins, then probability of introducing a new product is 0.3. Okay. What we have to find? See here, find the probability that the new product introduced was by the second group. So, probability of second group, that is E2, given that new product introduced. Okay. So, here let's take the event new product is introduced. Okay. Now, what is probability of E1? It is given, right? Probabilities that first and the second groups will win are 0.6. 0.6. Probability of E1 0.6, or we can write it in fraction, that is 6 by 10, right? Okay. Probability of E2 0.4, that is 4 by 10. Next, what we have to find? Probability of the second group, that is E2 given E, right? So what is probability of E given E1? That is probability of new product is introduced by first group, that is 0.7. 0.7, that is 7 by 10. Probability of E given E2, that is probability of new product is introduced by group, second group, okay, that is 0.3. That is 0.3, that is 3 by 10. Okay. Now, here we have to find probability of E2 given E. Right? Probability of second group wins given that the new product is introduced. Okay. So, here probability of E2 given E. That is, apply base theorem formula. Probability of E given E2 into probability of E2 divided by probability of E1 into probability of E given E1 plus probability of E2 into probability of E given E2. That is equal to probability of E given E2 3 by 10 into probability of E2 4 by 10 divided by probability of E1 6 by 10 into probability of E given E1 7 by 10 plus probability of E2 4 by 10 into probability of E given E2 3 by 10. That is equal to, here denominator, in numerator 100 that is cancelled. Okay. So 12 divided by, here 42 plus 12, that is equal to 12 divided by 54, that is equal to 3 fours are, so 3 6 are, right? 16. That is 1 by 4. Okay. That is equal to 3 fours are 12, 3 ones are 3 eights are, okay. That is 2 divided by 9. Okay. 2 by 9. Suppose a girl throws a die. If she gets a 5 or 6, she tosses a coin 3 times and notes the number of heads. If she gets 1, 2, 3 or 4, she tosses a coin once and notes whether a head or tail is obtained. Okay. If she obtained exactly one head, what is the probability that she threw 1, 2, 3 or 4 with the die? See here, two cases are there, right? That is, one is, see, when she throws a die, if she gets 5 or 6, then she has to throw a coin 3 times, okay? Or if she gets 1, 2, 3 or 4, then she has to throw a coin only once. Now, so here we will take, let E1 be the event getting 5 or 6, okay, and E2 be the event getting 1, 2, 3 or 4, okay. Now, what we have to find? See, what is the probability that she threw 1, 2, 3 or 4 with the die when, see, given that exactly one head is obtained, okay. So here let's take, let E be the event exactly one head is obtained or getting exactly one head, okay. Now what we have to find? Probability of she threw 1, 2, 3 or 4 with the die, that is probability of E2 given E, right, given E. Now, what is probability of E1? That is probability of getting 5 or 6. There are 6 numbers, right? When we throw a die, there are 6 numbers. That is 1, 2, 3, 4, 5 or 6. So, here out of 6, 5 or 6, that is 2. So, 2 divided by 6, right? That is 1 by 3. Now, probability of E2 is equal to 4 divided by 6. 1, 2, 3, 4 divided by 6. That is 2 by 3. Now, what is probability of E given E1? See, probability of E given E1. That is probability of exactly one head is obtained when E1, that is when she getting 5 or 6. See, when she getting 5 or 6, she has to throw a coin 3 times, right? So, when she throw a coin 3 times, what is the sample space? H, 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 T, T, H, T, 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 H, then H, T, 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 H, H, right? Then T, 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 H, T, H, H, then H, T, T, sorry, H, T, H, right? That's all. Okay. So, here probability of E given E1, that is probability of getting exactly one head when she getting 5 or 6. Okay. So, when she getting 5 or 6, she has to throw a coin 3 times. So, it is the sample space. So, here how many exactly 1 heads are there? That is 1, 2, 1, 2, 3, right? 1, 2, 3. Okay. So, 3. So, there are 3. So, 3 divided by 8. Okay. 3 by 8. Next, probability of E given E2, that is probability of exactly one head is obtained. That is probability of getting exactly one head when she is getting 1, 2, 3 or 4. See, when she is getting 1, 2, 3 or 4, she has to throw a coin only once. So what is the sample space? H, T, right? Either H or T. So exactly one head, that is 1, right? Number of H is 1. Okay. So 1 divided by 2. Okay. Now, so here we have to apply Bayes theorem. Okay. So what is the Bayes theorem? Probability of E2 given E. We have to find probability of E2 given E, that is equal to probability of E given E2 into probability of E2 divided by probability of E1 into probability of E given E1 plus probability of E2 into probability of E given E2. That is equal to 1 by 2 into 2 by 3 divided by probability of E1 is 1 by 3 into 3 by 8 plus probability of E2 is 2 by 3 into 1 by 2. That is equal to 2 cancel. So 1 by 3 divided by 1 by 8 plus 1 by 3. That is 1 by 3 into, here it is 3 plus 8, that is 11. 11 by 24. Right? 24 by 11. That is equal to 3 8s. So 8 by 11 is the answer. A manufacturer has 3 machine operators A, B and C. The first operator A produces 1% defective items, whereas the other 2 operators B and C produce 5% and 7% defective items respectively. A is on the job for 50% of time, B is on the job for 30% of the time and C is on the job for 20% of the time. A defective item is produced. What is the probability that it was produced by A? So here there are 3 machine operators A, B and C, right? So let E1 be the event item produced by operator A. E2 be the event item produced by operator B. E3 be the event item produced by operator C. Okay, so here what we have to find? So first of all look at this. A defective item is produced. Okay, so what is the probability that it was produced by A? So here we have to find probability of item produced by A given that item is defective. Okay, so here what is the event E? Event E is the item is defective. Okay, getting item is defective. Okay, now what is probability of E1? See, it is given that 50, see, A is on the job for 50% of the time, right? So here probability of E1, that is probability of items produced by operator A is nothing but 50%. That is 50 divided by 100, okay, is equal to 5 by 10. Probability of E2, that is also, that is B is on the job for 30%. That is probability of item produced by operator B is 30%. That is 30 by 100, 3 by 10. Probability of E3, 20%. That is 20 by 100 is equal to 2 by 10. Okay, now probability of E given E1. That is E is nothing but item is defective. So probability of defective item in the item produced by operator A. Okay, so defective, that is probability of defective item produced by operator A. That is here it is given, right? the first operator A produces 1% defective items. Okay, so operator A produces 1% defective items. That is probability of E given E1 is 1 by 100. Right? That is next probability of E given E2, that is probability of defective items produced by operator B. That is operator B, here operator B produces 5% defective items, that is 5 by 100. And probability of E given E3 is 7%, 7 by 100. Now what we have to find? We have to find probability of, that is item produced by A given that it is defective item, right? That is probability of E1, right? E1 given E. That is equal to base theorem, probability of E given E1 into probability of E1 divided by, there are three operators, three events, right? That is E1, E2, E3. So probability of E1 into probability of E given E1 plus probability of E2 into probability of E given E2 plus probability of E3 into probability of E given E3. That is equal to, substitute these values. So probability of E given E1 1 by 100, 1 by 100 into probability of E1 5 by 10 divided by probability of E1 5 by 10 into 1 by 100 plus probability of E2 3 by 10 into 5 by 100 plus probability of E3 2 by 10 into 7 by 100. See, denominators of numerator and denominator, that is 1000, it is cancelled. Okay. So here it will be 5 divided by 5 into 1 5 plus 15 plus 14. That is 5 divided by 20 plus 14 34. So 5 by 34. Look at the next important question. A card from a pack of 52 cards is lost. From the remaining cards of the pack, 2 cards are drawn and are found to be both diamonds. Find the probability of the lost card being a diamond. See, here there are two possibilities. Okay, two cases. Okay, that is lost card is a diamond and lost card is not a diamond. Okay, so here let's take, let E1 be the event. The lost card is a diamond. E2 be the event. The lost card is not a diamond. And see, after that 2 cards are drawn from the remaining 51 cards. Okay, one card is lost, therefore there are 51 cards, and we have drawn 2 cards from the remaining 51 cards, and it is found to be, they are diamonds. Okay, both cards are diamonds. So here let's take the event E. Here we have to find probability of the lost card being a diamond given that drawn cards are diamonds. Okay, therefore let E be the event getting 2 diamond cards. Okay, now what is probability of E1? That is probability of the lost card is a diamond. There are total 52 cards. Out of 52 cards, how many diamond cards are there? 13, right? So 13 divided by 52. That is 1 by 4. Probability of E2, that is the lost card is not a diamond. Probability of lost card is not a diamond. That means, see, there are how many cards are not diamond? That is, there are diamond cards, 13 diamond cards. Okay, so 52 minus 13, that is 39 divided by 52. That is, there are 39 cards which are not a diamond. Okay. So 39 divided by 52, that is equal to 3 by 4. Okay. Then probability of E given E1, that is probability of getting two diamond cards when the lost card is a diamond. See, if the lost card is a diamond, then there are one card is reduced, right? One diamond card is reduced. That is, there are 12 diamond cards. So for 12 diamond cards, we are selecting two cards, right? So 12 C2 divided by, there are 51 total cards, right? So 51 C2. Okay, in combination we have studied this one and the formula also. So here we will get 12 into 11 divided by 51 into 50. We just go through the permutations and combinations. Okay, next probability of E given E2. See here also, probability of getting two diamond cards when the lost card is not a diamond. If the lost card is not a diamond, then there are 13 diamond cards, right? After losing, there are still 13 diamond cards. Okay. So here 13 C2, from 13 diamond cards, that is 2 cards are drawn, right? So divided by total 51 cards, 51 C2. Okay. That is equal to 13 into 12 divided by 51 into 50. Now, what we have to find? We have to find probability of the lost card being a diamond. That is probability of E1 given that two drawn cards are diamonds. That is probability of E1 given E. That is equal to, from base theorem, probability of E given E1 into probability of E1 divided by probability of E1 into probability of E given E1 plus probability of E2 into probability of E given E2. That is equal to, probability of E given E1 is 12 into 11 divided by 51 into 50 into probability of E1 is 1 by 4 divided by, here probability of E1, that is same, 1 by 4 into 12 into 11 divided by 51 into 50 plus probability of E2, 3 by 4 into 13 into 12 divided by 51 into 50. Okay, so here see this 51 into 50 into 4, it is the denominator, right? So it is cancelled here. Then remaining 12 into 11 divided by, here 12 into 11 plus 3 into 13 into 12. That is equal to, see here we can write this as 12 into 11 divided by, we can take 12 into 11 outside. So 1 plus 3 into, here 12 into 11, right? So we have taken 11 outside. So it will be 3 into 13 divided by 11. So it is cancelled. Now it is equal to 1 divided by 11 plus 39. So 11 divided by 11 plus 39. That is 11 divided by 40, 50. So 11 by 50. Probability that A speaks truth is 4 by 5. A coin is tossed. A reports that a head appears. The probability that actually there was head is that. See here, first of all let's take E1 be the event, head appears, head, okay, and E2 be the event, tail appears, okay. when toss a coin, head appears and tail appears. And see, we have to find the probability of, actually there was a head, that is probability of getting head, given that, see, when toss a coin, A reports that a head appears, okay, a head occurred. So here, let's take the event, E be the event, A reports head occurred, okay, A reports that head occurred, okay. Now what is probability of E1? When tossing a coin, what is the chance of getting head? 1, right? So 1 by 2. 1 by 2. So probability of E2 is also 1 by 2. And what is probability of E given E1? That is probability of A reports head occurred when head occurred. Okay? A reports that head occurred when head occurred. That is when head appears. That means A speaks truth. Right? That means A speaks truth. So what is the probability of A speaks truth? 4 by 5. Probability of A speaks truth is 4 by 5. And probability of E given E2, that is when probability of A reports head occurred when tail appears. Okay? A reports head occurred, probability of A reports head occurred when tail appears. That means A speaks, so A speaks lie, right? That is 1 minus 4 by 5. So probability of lie is 1 minus 4 by 5. That is 1 by 5. Right? Now, next what we have to find? We have to find probability of getting head when it reports that head occurred. Okay? That is probability of E1, probability of E1 given E. That is equal to probability of E given E1 into probability of E1 divided by probability of E2 into probability of, probability of E1 into probability of E given E1 plus probability of E2 into probability of E given E2. That is equal to probability of E given E1 4 by 5 into probability of E1 1 by 2 divided by probability of E1 1 by 2 into 4 by 5 plus probability of E2 1 by 2 into 1 by 5. That is equal to 4 by 10 divided by 4 by 10 plus 1 by 10. 10 is cancelled. 4 divided by 4 plus 1, 5. So 4 by 5 is the answer. If A, B are two events such that A subset of B and the probability of B not equal to 0, then which of the following is correct? See here, it is given that A subset of B. Since A subset of B, what is A intersection B? Obviously it is A, right? Since, because A subset of B. Therefore A intersection B is equal to A. Now, what is probability of A given B? Formula is probability of A intersection B divided by probability of B, right? So probability of, say, if A intersection B is equal to A implies probability of A intersection B is equal to probability of A, right? So here probability of A intersection B is probability of A divided by probability of B. So it is not correct, okay? And say it is, we have got probability of A given B is equal to probability of A divided by probability of B. And we know that this probability value is between 0 and 1. It is not less than 0, right? So it is not negative, it is always positive and between 0 and 1. Therefore, it is clear that probability of A given B greater than or equal to probability of A. Right? Probability of A given B greater than or equal to probability of A. So this C is the correct answer.